Hello viewers, I'm Keerti Bhave. Welcome to this session on reduction of ore. This is third in the series of general metallurgical processes. After going through this video, you will be able to state the principle of reduction and explain the different processes of reduction of metal ores. Now let us see the different steps which have been carried out on the ore before reduction. The first step was crushing the ore, where the ore which is obtained from the mines is crushed into powder. The crushing is followed by concentration of the ore, where the gangue particles are reduced. The concentration of ore is done by gravity separation or froth flotation or magnetic separation depending upon the nature of the ore. Once the ore has been concentrated, that is, most of the impurities or the gangue have been removed, it is then converted into oxide. This conversion to oxide is either carried out by calcination or by roasting. After calcination or roasting, the metal is in the form of metal oxide. This metal oxide is then reduced. So the next step is reduction of the ore. Depending upon the reducing agent which is used for the process of reduction, the process can be smelting or aluminothermic reduction or electrolytic reduction. Now let us see the different reduction techniques in detail. After calcination or roasting, the metal is in the form of metal oxide. It has to be reduced to metal. That is, the metal oxide is chemically converted to metal. This is removal of oxygen, and therefore the chemical reaction is a reduction reaction. To carry out the reduction process, we require a reducing agent. Depending upon the reducing agents which are used, the process is called as smelting or aluminothermic reduction, or it can be an electrolytic reduction. We start with the smelting of ore. Smelting is a process when carbon in the form of coke is used as a reducing agent to reduce metal oxide. So metal oxide plus carbon gives metal. For example, the reduction of ferric oxide with the help of coke will give you iron and carbon monoxide. Zinc oxide is smelted to give zinc, and carbon monoxide is produced. Similarly, tin oxide on smelting will give you tin and carbon dioxide. Lead oxide on reduction using coke as a reducing agent will give you lead and carbon monoxide. So we can see iron, zinc, tin or lead oxides are reduced using coke as a reducing agent. During smelting, flux is added along with the reducing agent to remove the gangue. The gangue, which is the impurity, reacts or combines with the flux to give you a fused product called as slag. During the smelting of hematite, where silica is the gangue, lime is added as flux and calcium silicate is formed during the process, which is the slag. Smelting is carried out in blast furnace or in reverberatory furnace or open hearth furnace. Not all oxides can be reduced using carbon, and for reduction of such oxides, we use aluminium. And when aluminium is used as a reducing agent, it is called as aluminothermic reduction. The reduction of chromic oxide to chromium or the reduction of manganese oxide to manganese is done using aluminothermic reduction. The process of aluminothermic reduction is carried out in a crucible which is placed in sand bath. The sand to absorb the heat which is liberated during the exothermic process. To initiate the reaction between the oxide and aluminium, heat is required which is generated by carrying out the burning of magnesium, which starts the reaction between barium peroxide and aluminium. The heat thus produced initiates the main reaction. The metal thus formed is in the molten state. The crucible is covered with coke or charcoal powder to provide a reducing atmosphere. Now, oxides of certain metals can neither be reduced by carbon nor aluminium. The reduction of such oxides is carried out electrolytically. Metals like sodium, potassium, calcium, magnesium, and aluminium are extracted by electrolysis of their fused compounds. Let us revise the key concepts. The metal oxides are reduced to metal using different reducing agents. When carbon is the reducing agent, it is called smelting. For oxides, when carbon is not effective, aluminium is used as a reducing agent. The process is called as aluminothermic reduction. For oxides of compounds which cannot be reduced by carbon or aluminium, electrolytic reduction is used. I hope you have understood the concept of reduction and the different processes involved in the reduction. Wish you happy learning. Thank you.